Hi everyone, welcome back to Hard Problems Made Easy. Today we are going to look at serialize and deserialize binary tree. So we are given a binary tree, and this is the class definition for it. It is a simple value, right and left. Right? So we are given a binary tree, and we are asked to serialize it into a string. And we are also given a definition for deserialize, where with just a string, we should be able to like reconstruct the tree to its original form. So for our solution, we will be using preorder traversal. So let's do a quick refresher on what's a preorder traversal. If the root is processed first, and then the left and right are processed next, that's a preorder. In order is when left, root, and right is the order of processing, and post order is when left, right are processed first, and then we come to the root. So our solution is going to be a pre-order solution. Now let's go to the visualization. Here is a tree that we want to flatten into a list first, and after that eventually convert to a string. So what we are looking at is a pre-order traversal, and here is a signature for it, right? So we enter into the DFS, the recursive function. We first process the root and then process the left and the right. So this is the signature here. So we'll take for the first node and then place the value into the list. Now the recursive function goes to the left. Now we again process the left, put it into the list. Now this does not have a left and right, but we have some imaginary children just for our visualization. In case the left and right are null, we anyway append a hash in their place. Okay. So now this is processed in order, this is processed in order. So this entire left for the root node is complete. So we go to the right now. Okay. Now we go to the right and then place the value here, and then in order. So the root node in this subtree is processed. Now we go to the right. Sorry, we go to the left, and the left child, when it is considered a root, does not have any children. In their place, we put the hashes. Now we again go to the right child, put hashes in their place. Now this serialization is complete. What we'll do at the end is that we return with a comma separated string. You convert this array into a comma separated string. Now let's look at deserialization. So this is done. Now we are starting afresh. There is no tree. We are going to construct it from this string, and that is what this function is going to do. So the values is basically, put into an iterator. So we just give next of values, and then we keep getting whatever is the next here. So let's enter into the recursive function. The value is not a hash, so we start constructing the tree. We initialize a tree node, put the value into it. Now the left, we do a DFS, and right, we do a recursion again. So let's see how this plans. Okay, now the value is not that, so we construct a tree node and then make that the left child, which will be like, when the recursion depth reaches here, this will be assigned. Now for this two, we are again going into recursion. We go to the left, we go to this, it's right, and then the value is all hash, so nothing happens here. And we go back to the parent of the recursion depth, go to the right, place the 3 here, and then place the 4, and then those two children we do nothing, the hash children, and then we place a 5 finally. So this is how the code works. So this is in-order traversal, the same in-order signature you can see here. So we first process the root, whatever we have at hand, and after that we do the recursion for left first and then right next. And this is how it works. Hope this was useful. See you in the next video. Thank you.